If you are still copying Kubernetes YAML files for dev, staging, and production, you are not scaling. In fact, you are gambling because eventually you will update one file, forgot another, and will eventually break your production. And it won't be Kubernetes' fault, it will be yours. Hi, I'm Shivam, and this is the first video of a two-video series called Production Tooling. Today I will show you why real teams don't manually write YAML in productions. So let's head on to the demo section. So this is my local cluster. I have one control plane node and two worker nodes. Let's go ahead and we'll create a deployment for our dev environment. As you can see, the kind is deployment. The name of the deployment is app. It is using one replica and the image is Nginx 1.25 version. Let's apply our deployment. Our deployment has been created. Let's check it. So our deployment is up and running now. Now I will create a copy of my deployment dev to deployment prod. I will edit my deployment prod Nginx image 1.26 and 3 replicas. I will save it and I will apply this deployment. It says our deployment has been created. Let's check our pods. So as we can see, we have 3 new pods. So currently we have 2 YAML files for 2 different environments. Now imagine this. You update image in dev but forgot in prod. And here is where the drift begins and production incidents happen. The current architecture is not scalable at all. We need a more robust architecture where we need one template for multiple environments. And this is where Helm enters. So Helm charts are basically templates for Kubernetes application. Instead of writing and managing multiple YAML files manually, a Helm chart packages everything your app needs. For example, deployments, services, config maps in one reusable bundle. You can think of a Helm chart like a blueprint. The blueprint always stays the same, but you can change the values like image version, replicas, or even environment settings without rewriting the whole YAML. Instead of copying files from dev to staging and to production, you use one chart and just change the configuration. That's why Helm is so powerful in real production teams. Now we will look at how to install Helm on your local cluster. I have already installed Helm on my cluster, but I will show you how you can install it. Follow the steps mentioned here. I have used Chocolatey to install Helm on my local cluster. Feel free to pause the video here to install Helm on your cluster locally. So let's create our Helm chart using Helm create command. It says our Helm chart has been created and you can see we have a new directory called my app created for our Helm chart. So let's go inside this directory and we have multiple directories and files inside this directory. So the templates folder contains all the Kubernetes manifests. Values.yaml file is the configuration file for our resources. Let's explore values.yaml. So if you scroll up, you can see here it has a replica count. This replica count is for our deployments. Similarly, we have an image section where image is Nginx and currently it is not using any tag. Similarly, you can explore all these other options. So let me clear my screen and we will install our Helm chart using Helm install command. This dot specifies our current directory. It says installation complete. Let's check our pods. As you can see here, the last pod was created from our Helm chart. Now let's go ahead and we will update the replica count to 3. Again, I will be using Helm upgrade command. The name of the chart, the directory where it is located, and I am using -- set flag. And I'm setting the replica count to 3. It says upgrade complete. Let's check our pods. And we can see the last 3 pods has been upgraded from 1 replica to 3 replicas. So we did not edit our YAML, we did not copy our YAML, we did not do anything manually. We just ran one Helm upgrade command and Helm chart took care of everything. Now let's head on to environment files. I will create a file called values.yaml, and inside that I will update the replica count to 4 and the image tag to 1.26. I'm gonna save this and I'm gonna run helm update command to apply our values.yaml file. So it says upgrade has been completed. Let's check our pods and we can see the last 4 pods just came up 4, 5 and 7 seconds ago. Now if I do a describe on any one of the pods, I should be able to see the upgraded image tag. Let's check that. Yeah, if you see here, it is now using Nginx 1.26 image. So this proves that our upgrade was successfully done. So Helm chart gives you an advantage where you can update one template with different values, no duplication and no drift. Now let's look at versioning and rollback. If you run Helm list, it will list all the Helm charts on your cluster. Now I will intentionally break my app and I will set the image tag to something called does not exist. So if you see here, I am again using Helm upgrade command, but only this time I am setting a tag which is called does not exist. So it says our update has been completed. Let's check our pods and you can see here we are getting an error image pull error. So now let's check the history of our Helm. Using Helm history, so revision 4 is our latest revision where we deployed an image tag which says does not exist. So we have to roll back to revision 3. So I will roll back our app using Helm rollback command and I will include the revision number. So in our case, the previous working version was 3. So hence I am reverting it to revision 3. It says rollback was a success. Let's check our pod. Hopefully it should be up and running. So now you can see we have 3 pods which are up and running. So this recovers everything. This is a very handy feature for production. You don't need to manually clean anything. Just run a rollback command and everything will be back in seconds. So you see the difference. Helm gives you version release, environment isolation, rollback capabilities, and reusable packaging. This is how teams deploy in production and not by copying YAMLs from dev to staging and to production. In real companies, Helm chart live in Git. CI/CD runs, Helm upgrade install, Argo CD or Flux apply them automatically. So Helm is the bridge between developers and infrastructure. So if you are manually editing YAML files in production, you are one typo away from downtime. Helm doesn't just make things easier, but it makes them safer. Now you understand how production teams deploy in production. But Kubernetes alone is not production. After Kubernetes, you must understand monitoring, logging, security, and cloud native stack. Because deployment is just the beginning. In the next video, we will talk about monitoring, logging, security, and cloud native stacks. I hope this video was helpful. I will see you in the next one. Till then, keep learning.